Let's take a look at a few more Diels-Alder problems. So in the first problem, we have cyclopentadiene reacting with this cis-dienophile. So if we draw our curved arrows, again in the Diels-Alder reaction, we end up losing 2 pi bonds and gaining 2 sigma bonds. And when we use cyclopentadiene as our dienophile, or any kind of cyclic diene, we end up with a bridged bicyclic compound, which is going to look something like this. Okay, now we just need to decide where are our cyano groups going to be, and we know according to the endo rule, they will be pointing down like this. And just to emphasize that, I'll write the protons as going up. So the protons are in the exo position, but the substituents from our dienophile are pointing down, and they are in the endo position. So we end up with the endo product. Endo product. In the second example, this is called furan, this 5-membered ring with the oxygen in it. This is called furan. So again, this is our diene. Again, it's locked in the S-cis conformation. But this time our dienophile is trans. So again, if we draw our curved arrows, we see very simply that we're going to end up with a bridged bicyclic structure where we lost 2 pi bonds from our 2 compounds, and we end up with 1 pi bond. So we end up with a bridged bicyclic product again. But since our 2 cyano groups, since our 2 CN groups are trans to each other, we're going to end up with neither the endo nor the exo product, because one of them is going to be down and one of them is going to be up. And if I emphasize that by adding hydrogens, you can see that one of the hydrogens will be down and one of the hydrogens will be going up. So this is not exo and it's not endo. Okay, it's neither one of these things. So I'm just going to delete that now to point out that what you do have to add to this, the detail you do have to add, is that you are also going to get the enantiomer, the mirror image of this product. So let's take a look at the last example. The last example, again, we have our dienophile, our cyclopentadiene, but this time our diene is cyclopentadiene. Our dienophile this time is called maleic anhydride. It's a really interesting dienophile. So again, it might look a little bit more complicated, but if you just draw the curved arrow, so let's draw our curved arrows here. So again, we lose 2 pi bonds and we gain 2 sigma bonds. Let's start drawing our bridged bicyclic product. And you can see that the substituents, however you want to look at it, our 2 carbonyl groups coming off of our diene are coming off in the same directions. They're locked in a cis conformation. So that means we are going to end up with an endo product. And if we draw that out, if we just draw the 2 bonds from the 5-membered ring going down like this, and then we draw our oxygen in here, and then we draw our 2 carbonyl groups there, this is the endo product. And just to make this clear, if it helps, you can always draw in the protons to show the 2 protons are going up and the 2 bonds going down to the carbonyl groups on our ring are going down. So in this case, again, we also get the endo product. So endo product is preferred when we can get the endo product, but when we have a trans dienophile, then we get neither the endo nor the exo product. There is no endo or exo product, but we get a mixture of products. We get 2 sets of enantiomers. I hope this helps.